Hey everyone, on to the next one, A2A, multiplying polynomials by a monomial. And that's what our objective is. We're just going to be multiplying some monomials and polynomials together. It could be a monomial with a monomial, monomial with a binomial, monomial with a trinomial. Yeah, that's pretty much it. That's what we're doing here. So there's two ways I'm going to teach you how to do this for this lesson. The first way, we could use the distributive property. All right. Second way will be an area model. The distributive property, just whatever's multiplying, I'm just going to distribute it to whatever's inside of the parentheses. All right. So to do this, I have to make sure I do 2x times 3x. To do that, listen carefully. Now comes our exponent rules that we've learned about. I'm going to multiply my 2x and my 3x. That will give me 6x. But since each of these has an exponent on 1, recall when I multiply like bases, I add my exponent. So 2x times 3x is 6x squared. Okay? And then when I do 2x times 1, anything times itself is just going to be 2x. Well, no, anything times itself. Anything times 1 will be itself. Man, I'm struggling. So multiply this monomial by this binomial. I get this binomial here, 6x squared plus 2x. I cannot combine them because this has an x squared. This does not. I'm done. Now, let me show you how to make an area model for this. Same thing. All right, an area model is a two-dimensional figure. I'm sorry, we use a two-dimensional figure of a rectangle because I'm multiplying two things together. And I make my rectangle and I cut it. All right, it doesn't matter if I do my top versus my side on either the first term or the second term. So I took my 2x and I'm going to make my 2x going to be the height of this rectangle. I take my 3x plus 1, that's going to be the width, but I just split it into 3x and a 1. And now what I do is the area of this box would be length times width, or just 2x times 3x. And as I just did on the previous page, that's 6x squared. And the area of this box, again, it'll be length times width, which would be its width of 1. This over here, recall, if I swing it over, that's 2x. So this has an area of 2x. And my last step would be the total area would be if I just add those two together. All right, so it's very similar. I'm really going to show you how the area model is fantastic in a couple of lessons. But now the distributed property works just as nice, okay? So here's another example. I think this is the only other example because it's pretty short and sweet. For this one, I'm not going to make an area model because it's just a monomial times a trinomial. All right, so what I'm going to do, each piece I'm going to multiply. And I'm going to ask you what each piece is going to be. All right, so when I multiply negative x cubed times 9x to the fourth, my first question is, what will the exponent be? Hopefully you said 7. It'll be x to the 7th. And now what I do is I take my coefficients, 9 and technically a negative 1, multiply them, and I get negative 9x to the 7th. That's my leading term right now. Now I'll do x cubed times 2x. Negative 2x cubed. I know negative and a negative. I know I'm going to have a plus sign here. My exponents are 3 and 3. Add them together, I have a 6. And then negative 2 and negative 1 make positive 2. And now you tell me, what's my last term going to be when I do negative x squared times that 7? Again, negative 7x cubed. Did I say squared? I meant cubed. And now I have a very colorful standard form in this polynomial. Now, I'm going to do a quick little question. Classify this for me. And what is the leading coefficient? Good. And that's it. Time to get some work done.